Hello guys, I hope you're all doing well. In this video we will talk about lists in Python. This is one of the video from series Python for beginners. You can check them all collected in a list. I left a link above. Don't forget to subscribe to my channel and leave your reactions. It will really help me to create more videos like this one. Also, feel free to leave your questions in the comment section below and I will try to answer all of them. So if you find something unclear or you have some other questions, you could just leave it there directly. So now let's talk about what is list. So lists, it's a object type which commonly used in Python projects. Lists are Python's most flexible ordered collection object type. From a functional view, lists are just places to collect other objects, so you can treat them as groups. Lists also maintain a left to right positional ordering among the items they contain, which is mean that lists are sequences. The same as strings, as we discussed in another video. I left a link also here. So let's create some lists here in interactive Python prompt. So let me just type Python and create some lists to show you how they look and how to create them and what is list itself. So for example, we will create empty list. For that, we just need to do it just like that. Then we can create some list with some items inside this list. So for example, we will store different type in this list. So for example, we will have one string, we will have one integer, and even one float here. So we have a list that is contained with the three elements: string, integer, and float. Also, for example, we will create the third variable and assign it to the new object, which we will call list of the list. Why? Because we will store in this list as one of the element is another list. So list can have another list in the element. So we will also have some string here and some numbers. So this is also a list that contains three elements: 1, 2, 3. So this is how you create lists. You just need to use a square brackets and divide elements in the list by comma if there is more than one element. Just to be sure that all of these objects that we just created are list, we can check it using Python function type. So if we will check type for our empty list, we will see that it's list. Also, we can check type of our new list, and in the result it would be list. And you could guess that if we check list of list, it would also be list. So you see it here. So unlike strings, a list can contain any sort of objects: numbers, strings, and even other lists. So as we just saw in this example here, lists are mutable, which means that they can be changed. Unlike strings, if you remember, or if you're not familiar with the strings just yet, please check my previous video. It would really help you to follow this video with more understanding. So strings are immutable and lists are mutable, which means that list we can change and the strings we cannot change. So because list can contain other complex objects, they also support arbitrary nesting. So it's mean that you can create list of list of list of list and so on. So as we did here in our example. So this is called arbitrary nesting. So now I will show you the basic list operations and what you can do with the list. So we already know what is list, how to create them, and now I will show you what operations you could do with them. So items in the list are ordered by their position. So you can do tasks such as slicing, indexing, concatenation, repetition, find out length of the list, and etc. All of these operations may sound familiar if you're already familiar with the strings, because we did use them for strings as well, because lists and strings are sequences. So let me just show you what we can do. So firstly, we can check the length of our strings by using length function. So for example, we will check what is the length of our empty string, and it would be 0 because there is no elements here inside this. But if we will check, for example, our new list, it would be 3 because we have 3 elements in our new list. And even though in this list of list we have in this list of list we have one of the element as a list, but it just count as the one object here. So the length would also be 3, even though in this list there is 3 other objects. So the next operation that you could do with the list is concatenation, which means that you can add one or more lists between, and in the result got a new list. So for example, we could do it just like that by using our new list and add list of list. And in the result we will get a new list, which is the combination of these two, as you can see. You could also concatenate even the same list. If you want to have it twice, you could just do like that and you would have it twice. But for these cases there is another operations that you could use called repetition, and you could just do it easily just like that. So you could multiply it to 2, and in the result you will have this list 2 times. You can have it 4, 6 times, and etc., as many times as you want. So this is repetition. In these cases we have not changed our list with these operations. We created a new list in the result. List responds to all of the sequence operations that we used on strings in previous video, including iterations tools and in parameters. So for example, we can check whether 1 in our new list, and in the result we will get true or false. True if it's true, and false if 1 is not in new list. You could also check not in, and in this case we will get false, because if we will check our new list, 1 is in our new list. We can also iterate through lists using for. About iterations we will talk more deeply in the next videos, but I will just show you how to iterate through list as an example. So for I in our new list, for example, and then we will print I. So in the result we will get each element one by one printed. Lists are sequences, so indexing and slicing work the same way for lists as they do for strings. However, there is one small difference. The result of indexing a list is whatever type of object lives at the offset you specify, while slicing a list always returns a new list. So let me show you in an example what I mean. So the first is indexing. So if you remember, we start indexing from 0. So this is, if we will check the elements, this is the 0, this is 1, this is 2. So for example, if you want to find out which element are located in the first place in our new list, you should write new list 0. And in the result, we will get our string. And if we will check a type, what we got, we will see that it's string, because object that is placed on this first on this 0 index on the first place are a string. If we will check what is in our first, which is mean second place because we're starting from 0, we will get the result 1. And we know that 1 is an integer, and we can just recheck it to be sure, and you will see that 1 is an integer. So in the result of indexing, we will get whatever type of object lives in this offset that you specified. Also, with the list, you can also use negative offset. So if you want to get the last element in the list, you could just use -1. Or if you previous than last, you could use -2 and etc. So a positive and negative offset are supported as well. So now about slicing. With the slicing, the story is a bit different. So for example, let's slice our new list and we want to get the element from 1 to 2. So we know that this part is included, so 1 will be included and 2 is not. So in the result, as long as our length of the list 3, if you see it, we had our new list here. If you see it's 1, 2, 3. So in the result of this slicing, we will get the first element, but not the second, because 2 is not included. But you see that result of slicing, even though we have one number here, it's returned in a type of list. So if we will check a type, we will see that it's list. So slicing always return you in a list. But usually you will use slicing to get more than one element, of course. So for example, we would like to get all of the elements until the last one. So to do that, we could just use it like that. So we got first 2 elements. Or you could got all of the elements after 1. With 1 will be included, so we will got last 2 elements. Just like that. So this is slicing. One note here, because you can nest list and other object types within list, you will sometimes need to string together index operations to go deeper into the data structure. So for example, we have our list of list, as you remember, and inside this list we have another list. And using slicing, you can even get what is the object located in this list that is inside in our list in second position, for example. So how to do that? We will just write list of the list. It's just our name of our variable. Then we will put 0 because we know that our list is the first element here. And we want to find out what is in this list located in second place. So we will just use 1 here. And in the result, we will get 2. So you could, if you would have inside this list another list and etc., you could go even deeper and deeper and deeper and deeper and etc. So it's easy way to do that with the slicing. So the next thing that I will show you is how to change the list. So as I mentioned before, lists are mutable, so they support operations that change a list object in place. That is the operation in this section that I will show after that all of this operation will modify the list object directly, overwriting its former value without requiring that you make a new copy as you had it for strings. Because Python deals only in object references, this distinction between changing an object in place and creating a new object really matters. If you change an object in place, you might impact more than one reference to it at the same time. I will just show it to you in the example. So for example, how you can change the list. We can just assign, for example, we want to change our first item in our new list. We want to change it to something else. So for example, to change. So we could do it just like that, just writing the new list, our element and equal and what we want to change. And in the result, we will change our object, our new list. And now it's changed. So you see, we didn't reassign our variable, we changed the object directly. So let's do some experiments. So for example, let's create a new variable. We will name it shared, and this variable would refer to the object that our new list refer, just like that. So if we would, they are now pointing to the same object. So if we will check whether shared is equal to the new list, we will get true. And we can even check that the shared and new list are the same. So for now, let's change our new list again. So instead of our first element, we will add something like test, just like that. So obviously our new list is changed. So you see, instead of changed, now it's another string, test. But what about shared? What happened with this shared? Let's just check. You see that our shared is also changed. So this is the whole point, you changing the object itself. If you would remember that we did such an experiment with the strings before, the result would be different because strings are immutable. You cannot change a string like that. But with the list, if you're changing the object, it would be changed for all of the reference that were referred to this object. So for all of the other variables that refers to this object. And now I will show you how to change an entire sections. For that you can use slicing. So for example, you can check change for new list. So for example, you want to change new list. You want to change first two elements. So to do that, we will just write like that. So first two we will change to two strings, which would be 1 and 2. Just a mistake here. Just like that. So our new list, first two object, and then 1 and 2. And in the result, we would have our list change. And you see, at the same time, we changed two objects at the same time. We added 1 and 2 instead of test and 1 here was. And we also changed our shared, just to remind, because we do changing the object itself. For slicing, you can even do few interesting cases. So let me just show you them. So the first thing, for example, with the slicing, you can change like first two elements as we just did, but instead of changing them for another two elements, you can change them for another 4 or 5 or even 6 elements, just like that. Remember this 1, 2, we're changing, and we will change it to these 4 elements. And in the results, you see that we did change these 2 elements for more than one, just using slicing. Another interesting case that you could even just remove these 2 elements just like that. So you want these first 2 elements to be removed. In the result, we will see that they are removed. In effect, slash assignment replaces an entire section or column all at once, even if the column or its replacement is empty, because the length of the sequence being assigned, so it does not have to match the length of the slice being assigned to. Slice assignment can be used to replace by overwriting, expand by inserting, or shrink, as we just did by deleting the subject list. So it's a very, very powerful operations, but frankly, these operations you may not see very often in practice. There are often more straightforward and mnemonic ways to replace insert and delete, which Python programmers tend to prefer in practice, including me. The next thing that I will tell you is list methods. So as strings, Python list object also support type-specific method calls. You can check them all by just using by just typing in Python interactive prompt. You can just type help list, and in the result you will get all the information about list object and about all of the methods that you could use, how to use them, and etc. So let me just go in our interactive prompt again, and let's create a new list. We will name it methods, and it will be just 1, 2, 3, 4, 5, 6, just like that. So before showing you the methods, I want you to know that the methods we can divide by 2 sections. So the section is the methods that changing our object directly, and the other methods that not changing the object. So let me just show you what I mean by that. So the first method that we will check is append. So how to use a method? Just write our variable, just dot append, and here we need to add what value we want to append. So for example, we want to add 7. So this method will add an object at the end of the list. In the result, our object will be changed, and method is 7 is appended in the list. Another method is copy. This method is not changing our object, it's just returning a shallow copy of our list. Another one is count. For example, you want to count how many times 6 is in our list. In the result, you will get the number of how many times this value is repeated in our list. For us, it's just once. Another method is clear, and this method, what it's do, it's remove all items from the list. It's method changing our object. So if we would see, our list now is empty, and for me to continue I need to reassign it and create a new object again, because for now I have our method empty. Another one is extend. This method is also changing our object directly, and it's the same as append, but you can extend for more than one element at the same time. You can just use some iterable to extend our list. In the result, we will get the list extended. As you can see, all is added in the end. Next method is index. So you could, for example, you want to see the first index of the value. So you want to see what is the first index for our 3, for example. And the result, you will get 2, because 3 is located on the index 2, 0, 1, 2, just like that. This method is not changing an object, it's just returning you the result. Another method is insert. This method changing our object, it's close to append and extend, but here you can choose where you want to insert your before which index you want to insert. So for example, you want to insert something before 3, so you know that 3 is located on index 2, so you would just place the index, and before 3 you will add 1, just like that, and in the result you will get 1, 2, 1, and then 3. So you just inserted 1 before 3. Another method that is changing our object is pop. This method will remove and return item at index. So by default it would remove the last item. So if we will see, we have our 6 here. If we will check our method, it's removed, but also you could use it differently. You could set the index which you want to remove, so the value on which index you want to remove. So for example, we want to remove 1, so it would be 0, 1, 2, and you see that our 1 is removed, 1, 2, and there is no 1. Next method is similar to this one, but it's called remove, but instead of index, here you will show the value that you want to remove. So for example, we want to remove 2, and in the result 2, the first 2 will be removed, because you see we have another 2, but it would remove the first one, the first index of this value. Next one is reverse. Reverse is also changing our object. It will reverse our list just like that. So you see that the 5 now is first, and etc. Then the last one that I will show is sort. This method would sort the list in ascending order, and it will return none. In the results, we will have updated object. It would be sorted. You could use this method differently. So for example, you could use with reverse equals to true, and you will sort the method, the list in the descending order, if you would check in the result. So one warning here, so be aware that append and sort, it's changed the associated list object in place, but don't return the list as the result. Technically, they both return a value called none. So if you would do something like this, for example, we have our new list equal to new list sort, for example. So you wanted to have a sorted list in our new list. So intuitively you could do like that. In the result, you would not get what you expect. Sorry, we don't have a new list. We have a methods. So methods equal methods sort. So if you would do something like that, you would expect that in this methods variable, you will assign the sorted list. But it's not the case. If you would check our methods, it would be none. So you won't get the modifiable value. In fact, you will lose the reference to the list altogether. So when you use attributes such as append and sort, that changing our object, you don't need to do, so there is no reason to do the reassign. So that is all for the list. I hope you get an understanding and idea how to use them. I will show you more in the next videos with the example how to use them in the code and etc. So stay in touch. Don't forget to subscribe. Leave your questions in a comment below and wait for the next videos. So see you soon, and remember, knowledge is our superpower. Bye bye.